is reducible to linear differential equation. In that we are studying it is a Bernoulli's equation or Bernoulli's form. So we are having a one standard form of the Bernoulli's equation, that is this one I have written here, dy by dx plus py equals to qy to the power n, where n is not equals to 0 or 1. So this is the Bernoulli's equation. Excluding the 0 and 1, this will be the Bernoulli's equation then. Now suppose if I put the n equals to the 0 here, what will happen? Y to the power 0 हो जाएगा ये, y to the power 0 is what it is? 1. So the equation that I have written here, I put the n equals to 0 in the equation, okay, where if I put the n is equal to 0, I get this equation, and this we know that this is nothing but the linear differential equation which is linear in y, okay, and can be solved by the linear concept. Same way if I put the n equals to 1 here in this equation, अगर मैंने 1 put up किया तो what will happen? 1 यहाँ put up किया तो this will be the y. I take this py to the right hand side, take y common, q minus p. Now note that this p and q will be the functions of it is only x or maybe a constant. ये functions of x रहेंगे नहीं तो constant रहेंगे p और q. Okay, this q and p are the functions of x. We suppose this is y. Now this is the dy by dx equals to, we are having this quantity. So y I take here, dx we take here. Okay, to the RHS part. So can be written this, that equation can be written into this form. That is we have separated the variable. हमने variable separate किया, dy and terms of y on one side, dx and terms of x on other side. Okay, so this can be solved if this things are integrable. अगर ये integrable form में है, so we have a solution for this differential equation. So we are observing here, if I put the n equals to 0, this equation reduces to the linear differential equation, and if I put the n equals to 1 in this equation, then this equation reduces to its variable separable form. Okay, so that's why in Bernoulli's equation we especially mentioned that n should not be equals to 0 and 1. So this is the Bernoulli's equation standard form, that is dy by dx plus py equals to qy to the power n, where this p and q are the functions of independent variable, it is x, or that may be a constant. ठीक है, अब इसको हमको सॉल्व करना है. वी हैव टू चेक हाउ टू सॉल्व दिस Bernoulli's equation. ठीक है, सो हम कैसे सॉल्व करेंगे? आई हैव ऑलरेडी टोल्ड यू इन द फर्स्ट फॉर्म दैट whenever we solve the equation by the reducible to linear differential equation, तो RHS part of the equation must be a function of independent variable, वो होना चाहिए. तो यहाँ पे independent variable क्या है? It is x. तो RHS part में सिर्फ x के टर्म्स होने चाहिए. We know that q is a function of x, तो q यहाँ पे रहेगा. So that's why I divide this equation by y to the power n. ठीक है, इसको y to the power n से मैं डिवाइड करूँगा. यहाँ पे इक्वेशन में फिर से लिखा, y to the power n से डिवाइड किया, 1 upon y to the power n here, again y to the power n is here. Now this goes up, that is y to the power minus n, and इसको भी ऊपर लिया y to the power minus n. बेसिस सेम है, पावर ऐड हो जाएंगे, यहाँ पे पावर 1 है, यहाँ पे माइनस n है. So this I have written here, y to the power 1 minus n. So if you observe, the derivative of this quantity can be this one. हम देख चेक करते हैं उसको. I substitute this quantity as v. Now take a differentiation with respect to dx because we require dy by dx. ठीक है, इसलिए हम उसको x से डिफरेंशिएट कर रहे हैं. तो डिफरेंशिएशन में ये क्वांटिटी यहाँ पे आएंगी, then y to the power 1 minus n minus 1, because we know the integration of x to the power n dx, that is n x to the power n minus 1. So same way we are following here, 1 minus n here, y to the power minus n, then the derivative of y, that is dy by dx, then the differentiation of v with respect to dx, dv by dx. Okay, now I take this constant 1 minus n to this denominator here, or dividing this by the 1 minus n, we get this quantity. So this is nothing but it is the first term in the equation. So this will be replaced by this 1 upon n dv by dx. This is p, and this we have taken as a v equals to q. So this is we have got this equation after substituting these values here. And now after that, when this, if you are observe this equation, so the coefficient of dv by dx is 1 upon n minus n. So I divide this equation by the 1 minus n to convert this equation into the linear form. Okay, because linear form में क्या होता है, the coefficient of the differential coefficient that always should be it is 1. तो 1 लाने के लिए मैं इसको 1 minus n से मल्टीप्लाई कर रहा हूँ. ठीक है, 1 minus n से मल्टीप्लाई किया तो dv by dx 1 minus is multiplied here, और यहाँ भी मल्टीप्लाई होगा. Now if you observe, this is the linear in v, this equation. बिकॉज v का डिग्री 1 है, dv/dx का डिग्री 1 है. So we have reduced Bernoulli's equation to the linear differential equation. Now the linear differential equation can be solved, okay, by the concept that we know. The solution for this equation will be given by, it is dependent variable which is v into the integrating factor e to the power integration of p dx. Okay, so integrating factor, sorry, यहाँ पे आ जाएगा p dx नहीं आएगा because 1 minus n is also here. This will be the integration of 1 minus n into p dx, constant we have to take into the account, equals to then integration of this RHS part and then into the again that integrating factor, it is 1 minus n into it is p dx, okay, plus c. This will be the solution for this equation. But given equation का solution चाहिए तो हम क्या करेंगे, तो will replace the v by what we have taken, y to the power 1 minus 1. So that will give the, it is solution for the given Bernoulli's form. Okay, so this is the first form we have seen, that is the dy by dx plus py equals to qy to the power n. वैसा फिर एक फॉर्म हमारे पास रहता है dx by dy का भी आ सकता है in the example. So we may have the form of this type, dx by dy plus px equals to q x to the power n, where this p and q are the functions of independent variable and what will be it is now y or maybe a constant term. ठीक है, तो अब इसको सॉल्व करना है हमको. तो आई हैव टोल्ड यू दैट RHS पार्ट शुड बी अ फंक्शन ऑफ इंडिपेंडेंट वेरिएबल ओनली. तो मैं इसको x to the power n से डिवाइड करूंगा फिर. ठीक है, आई डिवाइड बाय द x to the power n, आई गेट हियर देन x to the power minus n आफ्टर डिवाइडिंग x to the power 1 minus n, और इसको हम पुट करेंगे, इट इज व्हाट v. इसको v पुट अप करेंगे तो आपका डेरिवेटिव यहाँ पे आ जाता है और इक्वेशन में सब्स्टिट्यूट करने के बाद वो इक्वेशन लीनियर फॉर्म में कन्वर्ट हो जाता है फिर. ओके, that will be the linear in v and linear differential equation can be solved by the formula already we are having. Okay, so this way we solve the example on the Bernoulli's equation. Bernoulli's equation comes under the, it is a reducible to linear differential equation. जो concept आपने already देखा हुआ उसके लिए same we have to apply here. Okay, but we are having a one standard form. वो equation है एक जो Bernoulli ने यहाँ पे evolve किया हुआ है, that we are using here with the condition that n is not equals to 0 and 1. Okay, thank you.